Hello engineering students, this is Mr. O, and we're going to go through method of joints again, but with a second question. The previous question, what we did was we did the method of joints. As you can see, I'll move this into the middle. We did method of joints around a really small Warren Bridge truss, and instead of just doing that particular example, I'm going to move into a more of a Howe, I think this is a roof truss, a Howe roof truss. And so let's jump straight into it. The first thing I am going to do is I'm going to draw this truss. But let's have a look at, by drawing it, it's going to give me a good example of what is happening in that truss. My drawing is not very straight there at all. And because I am doing this, the question will ask something like this. Find the supports, or find the reactions at the supports. Is probably going to say something like, what have we got? U and Z. This question is going to say, find the reactions at the supports of U and Z. And at the same time, find the force in every member across this Howe roof truss. And what we can see is that we have a force applied to joint R of 22 kilonewtons and also 10 kilonewtons applied to joint T. We also know that from there to there is 6 meters, and from there to there is 6 meters. So we've got 6 meters across there to there, 6 meters across there. Oh, they've given us the angle as well. 43 there and 43 there. So we have and 43 there. So this is telling us that we have a triangle that has this side the same length as, well, same length as that side. Height wise, it actually doesn't tell me. That's okay, but I have my angle 43 degrees. If that is like that, then you would know that it is going to be 3 meters from there to there and 3 meters from there to there. I've just forgotten the name of that triangle. Oh, I will make sure I remember it next time. And there we go. We have our triangle drawn. So what we're also going to do now is I'm going to list all of the members that I have to solve. That will probably also ask you in this type of question when we're doing method of joints. The question will outline specifically, find the members find the force in every member. So we have members U, R. We have a member UX. We have a member RX. We also have XZ, there to there, TZ, and TX. All in all, we have 7 members to find out what their forces are, their internal forces, because we have 2 external forces, being the 22 kilowatt and the 10 kilowatt. We will also have 2 external forces, which is going to be the supports themselves holding up this roof truss. When we find the forces, we also will find then the direction. That they are they either in compression or are they in tension? So let's go ahead and solve that. Before we do that, we need to work out what the forces are. And so what I do is I take moments about the first support being U. Moments about U equals 0. And I'm going to say sum of my moments counterclockwise equals the sum of my moments clockwise. And I'm going to just draw this like that. I have U there, I have Z there, I have 22 there. I'm noticing both are 22 kilonewtons and 10 kilonewtons, so I have a good idea of what the I have consistency in my units. So I'm just going to put the numbers down. And I know that from the left-hand side to there, it's 3 meters. And from U to X, it is 6 meters. And across, it's going to be 12. Very quickly, I'm going to do this example, doing the minimal amount of working out on my page. I'm going to try and squeeze this all into one page to see how we go. So if I take moments around U, at that particular point, I have the equivalent of going clockwise. I have 22 times 3 meters. I have 10 plus. That force is 10 meters perpendicularly from point U, and it's 6 meters away. That will cause my pivot point. If I have a beam like that, it'll push down, it'll cause it to go in a clockwise motion. This one will also cause it to go in a clockwise motion, which is why I put it on the clockwise side. And the only other force I have now is pushing that way. I'm going to assume it's positive. I'm going to assume it's up, that support holding that roof truss in place, which is going to be counterclockwise, and that is going to be the reaction at Z, and it is going to be 12. So 12 RZ. Let me solve that quickly. So that would be, open brackets, 22 times 3, close brackets, plus, open brackets, 10 times 6, 126, divided by 12. My reaction at Z is going to be 10.5 kilonewtons, and it's going to be upwards, supporting that. It's positive as well. And then very quickly, sum of forces vertical, because now I can just add up the other forces. That is going to be sum of my forces down equals sum of my forces up. I'm not going to write those all of the time. I've written them here already, knowing that this entire truss is an equilibrium. My forces down will always equal my forces up. My moments will always equal clockwise, counterclockwise moments will always equal the sum of my clockwise moments, and it'll be the same for horizontal. So straight away I have forces down, 22 plus 10. 22 plus 10 equals 10.5 plus whatever's pushing up, which is going to be the reaction at U. My reaction at U is 22 plus 10, obviously it's going to be 32, minus 10.5. I did something wrong there. 32 minus 10.5, 21.5 kilonewtons, and again, it's positive, so it's going to be upwards. Okay, so I'm going to draw a bit of a thing down the side here, a little barrier, and I'm going to start at the most obvious place. I'm going to start at point U. Start in the left hand corner, and the first thing I'm going to do is I'm going to go joint U. Tell the person who is going to be marking your paper or your sum, I'm starting at point U, and I'm going to say the forces vertical should say sum of forces equal 0. I know my sum of my forces down will equal my forces up, and what I do is I look at that joint and I draw that joint. And method of joints are now, and I was going to get another piece of paper. Let me quickly try and find, I'll get myself a little sticky note. I always seem to forget the sticky note. What I do, I'm going to resort to this side here. I can do it on both. I ignore everything else to the other side of that. I can see through my sticky note. I ignore everything else, and I look only at the members UX and UR before they reach the joints. And that's method of joints. You ignore everything else. So what I do is I look and I see what external force is being applied to U. And at the moment I have found that the reaction is an upward reaction, an external force of 21.5 kilonewtons going upwards. And because I'm doing vertical, I can only work with forces that are going to be vertical. So what I do is I look at UR and I say, well, I don't know, that is going to be the hypotenuse of the vertical here. This is the opposite. And so if I look very briefly and think I'll write on my sticky note, straight away I look at my triangle like this. My vertical is going to be here. Those two are going to be the same. And in order to find UR, which is actually this little triangle, is the hypotenuse, opposite over hypotenuse equals sine this particular angle, which happens to be 43. So if I want to find out what this is, I can inadvertently find out what UR is. So what I do is I substitute my opposite equals hypotenuse sine 43, sine that angle, which is 43. If I put that in place of what I'm going to call force UR vertical, opposite is force UR vertical, equals the force of UR times sine 43. I don't know what it is. I don't know which direction it's actually going. I don't know whether it's in compression or tension. So I assume it is in tension. I assume it is positive. So what we can see straight away is that both of these are traveling in the same direction. They're both going up. They're both forces up. So if we look back here, forces down equals forces up. I have no forces going down. So it is 0 equals, what's my force up? 21.5. That's my UR, my RU, plus my FUR vertical, which, as I've just worked out here, is force of UR sine 43 degrees. And I just solve this quickly. The 21.5 will go to the other side, become negative 21.5 equals FUR, and I divide that by sine 43. That's my force in UR. So let me work that out. Negative, for the sake of keeping it negative, because it's gone over there, divided by sine 43. And that is negative 31.5. I'm going to round it up to 3 kilonewtons. What that also tells me is that it's negative. Therefore, it's in compression. So what I'm going to do now is when we go up to here, say UR is, I'm not going to put the negative there. I'm going to say 31.53 kilonewtons. And I'm going to put a C there saying it's compression. So I've solved that. I've saved that already. And I know that if it's in compression, the force, remember, the internal force is going towards the joint. And on the other side, it's going to be pushing towards the joint, because in tension, the force is going away. At the same time now, I'm going to jump from just looking at the verticals, I'm going to look at the horizontals. And so what I do is I go, sum of the forces horizontal equals 0. I have not put that formula down yet, so the sum of the forces in this direction equals the sum of the forces in that direction. I'm going to put a little bubble. I'm not going to draw this again. I'm going to follow that same pattern throughout my entire solution of each of the joints. But let me have a look at this. What have I got? I have got a joint, but I've got an angle at U. So that is point U, that is joint U. I have got a force that's at an axial load. It's at an angle, 43 degrees from the horizontal. So also, not only am I going to have I'll bring another little one in here. Not only do I have a force which I found out is traveling in that direction, because I found out that UR is actually in compression, so technically it's going like that, I have a force that is traveling at this joint in that direction, a horizontal force. So what I have is I have a force traveling into that joint, which is my force UR horizontal. And what I'm actually trying to do now is solve for UX. I don't know what direction UX is going, but it is horizontal and it's traveling away. I don't know what it is, so I assume it's positive. I assume it's in tension, which means it's traveling away from the joint, and that is force UX. I've got this force going in that direction, so I've got FUR horizontal, and I've got force UX going in the other direction. Force UR horizontal traveling this way, equivalent of that would be force UR cos 43. Look, I knew what that was. I didn't know what that was. I can find that because I have UR. I don't know what that is. So let's work that out quickly. FUR is 31.53. I don't put in the sign because I've already allocated the distance, or the direction. The direction is going in that direction there, I know, because my resultant would be, if I got a force traveling to a point in this direction there, then the vertical should be traveling that way for the resultant to be traveling that way. So therefore my horizontal has to be going that way for my resultant hypotenuse to be having that type of force. So 31.5, 3 cos 43 equals F force of UX. Let me work that out. 31.53 cos 43, 23 plus 23.0, I'm going to just say 0.6 kilonewtons equals force UX. It is positive, therefore it is in tension, which means it is going away. You will find that a question like this might also ask you to do the force diagram at the end. Technically, I'm just drawing my force diagram together on this already. So let me go up here. UX is now 23.06 kilonewtons, and it is in tension. I'm now going to go to the next step. I'm going to just put that there. I have exhausted all my calculations around the joint U. To simplify my life, I think I'm going to go to the joint Z. I'm going to do the same thing there. Work out what the vertical of TZ is, and at the same time work out what ZX is, because I can use the horizontal equivalent of TZ. And I will find TZ by finding its vertical by doing method of joints there. So I'm going to go joint Z. Sum of my forces vertical, easiest way to start. Forces down equals forces up. I'm going to redraw the little joint. And I'm going to say, what external forces do I have acting on that joint? I have the supported Z. Supported Z, which is 10.5 kilonewtons going upwards into the joint. I don't know what the vertical of TZ is. So I'm going to just draw a line there. I'm going to say force TZ vertical. I don't know what it is. I assume it's positive. I assume it's in tension. Therefore, it's going away from the joint. Remember, I blocked out everything else out there. And that's it. That's the only things I need to work out now. So therefore, I have no downward forces. I only have upward forces. So I have 10.5 and force TZ vertical, the same as over here, the same as I did it's going to be plus force of Tz, which is the hypotenuse, sine 43. And pretty much similar to that, what's going to happen is that's going to go to this side. It's going to become a negative 10.5 divided by sine 43 is force of Tz. Let's work that out. I know it's negative, so I'm not going to type it in. Oh, let me do the right thing. Negative 10.5 divided by sine 43. It is negative 15.4 kilonewtons force Tz. Aha, it's negative. Negative tells me that it is in compression. Straight away, Tz, I've solved Tz already. See how quickly you can get through this. 15.4 kilonewtons, and it is in compression. Compression means the forces are going towards the joint. That's going to dictate to me what the horizontal force and which way it is traveling. Let me do that now. Sum of the forces horizontal equals 0. I've already got my little forces going this way. The sum of the forces this way. I'm going to get the sum of the forces this way. So I draw my little... I keep forgetting to put the label there. Z. Now I've got Z. As I drew before, here's Z. I know that I have Tz being in compression, so it is pushing into that joint. I worked out already that if it's doing that, the resultant vertical and my resultant horizontal have to be traveling in that direction in order to make the resultant of my hypotenuse that. So I know straight away that the force Tz horizontal will be going into the joint. But I don't know what Xz is. Force Xz, that's my question mark. I knew what that is. I didn't know what that is. I solved it. I can now solve for that because I have what Tz is, but I don't know what that is. Therefore, it is going away. It is positive. It is tension. And force horizontal is 0. Therefore, all the forces to the left is going to be force Xz equals force Tz horizontal. Force Tz horizontal going into the joint, and my unknown force Xz going away from the joint. So force Xz equals, what is FTZ? That's going to be the sine of, that's the horizontal sine of that angle there. So it's going to be FTZ. I'll write it out for you now. I might not do it in the next few because I will run out of space by the looks of it. FTZ, because I know what that is, cos 43. If XZ is, and again, I've already decided right is going that way, and I've already allocated the direction, so I leave out the negative. So then I go 15.4, I ended up there quite a bit, but yeah, we'll make it 15.4, divide, no, cos 43, 11, it's plus 11.26 kilonewtons. It's positive, therefore it is in tension. XZ. Did I write down XZ here at all? UR, UX, RX, XZ. Oh, I wrote that in the wrong place. 15.4 kilonewtons. Compression. Sorry about that. 11.26 0.26 kilonewtons tension. And what I do now straight away, it's in tension, so my arrows are going in the opposite direction. So there we go. I've solved that one, that one, that one, and that one. Now we get to some of the tricky parts. I've exhausted that and I've exhausted that. I think I might just jump to now this one here. Now, that could be a bit tricky, trying to go straight to, so I'm going to say joint X. It's going to be a bit tricky trying to go to the vertical straight away. And the reason why is because I have no idea what that is, and I don't know what that is. But I can find, I don't know what Rx is, but I can find Rx is horizontal because I have both this horizontal force and this horizontal force going into there. Remember, we isolate everything around the joint, and if I'm going to do horizontal work, I am only going to work with forces that are traveling in this direction. I resolve angled forces or axial loads, axial forces into horizontal. I can't because this is perpendicular. So therefore it'll be that one to there, and I've got that side and that side. So let's draw that. I'm going to go sum of my forces horizontal, and I'm going to draw X here. What do I have? Straight away I can see I have force UX. I know what that is. And I also have, because remember, at that joint, both of these members, UX and XZ, are in tension, so their internal forces are pushing or pulling away from the joint. I also have force XZ in horizontal. Okay, they're both horizontals. I don't know what Rx is horizontal. It's in this particular direction. I want to find its horizontal. I don't know which way it's going, so I'm going to assume it's traveling away from the joint. So what I'll do is I'll go force Rx horizontal. So I have two forces going left and one force going right, and I jump straight back to here. I put my left forces in that way and my right forces on that side. So what do we have? We have FUX. This is where you're going to be tricky, because if you start putting the wrong numbers in the wrong places, you might get the answer wrong. 23.06 plus. I'm working with the horizontal version there, horizontal of Rx, but that's going to be the force, the hypotenuse, force of Rx, that's how I solve it, cos 43 equals whatever's going in that direction. XZ is, now that I've got it in the right place, 11.26, and that's it. So I go FRX equals, so it's going to be 11.26. This will go to the other side, it'll be subtracted, minus 23.06 equals, divided by, so I'll put there, negative 11.8 divided by cos 43 degrees, FRX, divided by cos 43, negative 16.13 kilonewtons. Again, I state it is negative, therefore it's in compression. Rx, 16.13 kilonewtons compression. I now know what that is. It's compression, so it's traveling away. Oh, mistake. See, straight away. So simple, so quick. Towards the joint. It's in compression. It's going towards the joint. Now I have what that is. If I do sum of my forces vertical at joint X, I ignore those horizontal, and I have TX, and I have Rx. I've only got 2. I don't know, well, now that I know that that is in compression, is forces going into the joint. So into the joint is force Rx vertical. I don't know which way Tx is going, so I assume it's in positive, it's just in tension. So I can work that out easily. And I've got force Tx, one going up, one going down. Force, some of the forces going up equals force, some of the forces going down at that specific joint. So that becomes quite easy. Rx 16.13, forces going down, sine 43 equals Ftx. And that's it. Force Tx 16.13 sine 43, 11 kilonewtons. It's positive, therefore it is in tension. Yeah, I actually left one out here. There's not 7, there's 8 there. 11 kilonewtons in tension. So it is in tension. Tension is moving away. I forgot to put RT. I'll put it up here. In order to solve for RT, it's probably easier to jump up to joint T. And at joint T, I'm just going to do a sum of the forces vertical equals 0. That's going to be easier because I have the TZ's vertical. I can resolve to find the vertical. I have TX. I also have this external force of 10. And I can find RT because I can find its it's a hypotenuse, so I can find its equivalent vertical, which is going to be the hypotenuse sine 43, because the whole triangle is 43. So let me draw this joint. This is going to be interesting. Straight away, my first external force is going to be down 10 kilonewtons, and my pen's going funny. What else is happening? I now have also going up into the joint, I have the force TZ going up because TZ is in compression. TZ is in compression. I have going, and that's its vertical equivalent. I have going away from the joint, also going down now, not into it, not up, but down is TX, force TX. And I don't know what the equivalent horizontal is, vertical of force RT. So force RT is, I'm going to assume it is going away from the joint. And that's only because I don't know what it is. I'm going to assume it's in tension. Therefore, it's going to be positive. So therefore, force RT vertical. So I've got all the equivalent verticals going in one direction, or in whichever directions they are. So I have forces down versus forces up. So what forces down do I have? The one I want to find, which is force RT vertical, which is going down, plus force TX, which is also going down. I also have the 10 kilonewtons for my external force. And going up is my force TZ vertical. That was already a fully vertical. So let me just sum these up then. Force RT is really going to be force RT sine 43. I hope you guys can still see this. If TX is 11 plus the external, because it's also going down, and TZ is 15.4. or the TZ vertical. I did not take into consideration that TZ vertical is going to have to be sine as well. Going to make sure of that. Just realizing now, 43, I'm already running out of space on this poor page. So I'm trying to find that guy. So let me sort these all out. (15.4) sine 43 is 10.5. Subtract 10, subtract 11, divided by sine 43, which gives me FRT equals negative 15.39 kilonewtons. 15.39 kilonewtons. It is negative. Therefore, it is in compression. So there we have it. And if you do what I do sometimes to verify afterwards, when I've been doing these types of calculations, I go into some truss analyzers, and I'll verify what my answers are. We can actually double check them. If you look closely, UR is 31.5 compression. UX is 23.6. RX, which was that one up there, as we can see, I think I've pushed this right out there. What was UX? I've done that one already. RX 16.5 negative, so you can see it's compression. XZ 11.26 kilonewtons. TZ there to there 15.4, and TX was 11, and in the end the last one 15.4, that's it, or 15.39 compression. 100% correct. So guys, I hope that has helped you. I hope that has helped you in your understanding of method of sections. Oh, sorry, method of joint. My next thing I'm going to do is method of sections. Hope that's helped you guys, and I wish you well in all of your future method of joints calculations.